are discussing about the biometric security, right? That you have the system, and what are the weak points in your system, that has to be understood carefully. And this is the classification of biometric system, whatever it is. And Maltoni is the person who wrote this, who have just previously I told the Wayman's classification. Here it is a Maltoni's classification. And the first point is the circumvention. What it tells? That it is an attack that gains access to the system by some technical method to sabotage your biometric system, right? So, this attack can be the sabotage the computer system. What it means? That you want to override the measure, that measure tells fails, but you did some manipulation, you make it no, it is accept. Now, this first one is that you can sabotage the whole system, computer system itself. What it means? That not the hardware you will be sabotaging, you are sabotaging the matching algorithm or feature extraction algorithms. There you do some manipulation that a person who is supposed to get yes, you can make it no, right? Or no, you can convert into yes. Another one is that whatever irrespective of feature you get or matching, you just replay the old data. Suppose I want that he should be failed. So, I got the feature from the concerned persons, but instead of using that feature, you use your own available features, so that he will be failed, or you want to make him pass always. So, whatever feature you extract from the image, but you put such one that which is always making it accept. That means, is old data you are, old features you put it and make it accept. So, these are the two ways you can attack the system. This is circumvention. Then covert acquisitions, right? And you know that covert acquisition means that it is not that your involvement is required to provide your data, and that is the use of biometric information captured from legitimate use to access the system. So, I am the genuine person, I captured the data, you have captured my data, and that information I will be using for my purpose. So, examples are spoofing, that is via capture and playback of the voice, what signature, whatever this there, that you will be playing back, or there is a somewhere you gave your fingerprint, I have taken the photograph of it, and then I extract the features, I use it for further purpose. This category can be considered to cover the regenerated biometrics template. So, what happens that once you get this latent fingerprint, now from that fingerprint you have to regenerate the features, right. Similarly, from the features you have to regenerate the fingerprint also. So, even though one can think that from the feature I may not be able to regenerate my fingerprint, but the people have started working on it, that is it possible that given features can I get back the original image, right. So, that work is going on. So, the regeneration is an important parameter here. Collision and coercion. Now, collision, this is one thing you remember, that this occurs from the legitimate user only, right. Sometimes what happens that the legitimate user also wants to break the system. So, what are the possible cases? In the case of collusion, he is willing to get it rejected. I want to provide my data in such a way that I get rejected, right. That is possible case, that if I get rejected, then others will be benefited. So, what happens that I tell you that you get rejected, then I will pay you X amount of money. So, obviously, you will tell okay, there is no problem, if I get the X amount of money, I am ready to sacrifice my thing, right. So, this is under collusion. The coercions, here it is the reverse one, that he is not ready to give the biometric, he he is not willing to sacrifice his stand. Yes, I will give the data to get it accepted, but here I am giving you threatening, or I am blackmailing you that you have to get accepted, so that I get benefit from it, right. So, these are the two conditions, and in that case there is no way you can, because in both the cases user is legitimate, genuine user. So, it will be true. So, you cannot detect that attack. Now, the denial of services is also another type of problem here we are facing, that this attack prevents a genuine user to use the system, right. Now, how can it be possible? This can be in the form of that you can make the system stop, or slowing down your network, or that you reduce the performance of the system, right. So, how can you reduce the performance or degrade the performance? The degradation can be done, say, once you extract the features, you can put a lot of noise on it, and once you have put the noise, there is a possibility that there will be too many false feature points, and as a result that genuine persons will be rejected. So, he will be denied from the service, right. Or another way could be that you have put a lot of load on your network, the system gets slow, right. Now, a legitimate user, he comes, he wants to prove himself, but because of the slowing down system, it is taking huge amount of time. So, the person will tell no, because generally what we put, that we put some time constraint, that if it is beyond this period, you tell that rejected. So, he will be thrown out, and again he will be denied. So, generally in such cases what happens, that users or the industry will tell oh, this system is no good because it is giving you a lot of problems. So, let us change it, and once you change it, that means that the concept of handshaking will come in between, right, that compromising with the other one, that means circumvention and other factors will be introduced in that case. It will be easy for reputation is one thing that you cannot deny that you have done this thing, right. So, a legitimate user has come and he has given the data, and he should not tell no, I have not done. But there are some places where you may find that I have given the data and I am claiming that no, I have not given the data, my data has been stolen, right. My voice has been stolen by somebody. This you get very frequently whenever forensic science problem comes, that you will find that it is not my voice, it is somebody who has copied my voice, right. And this is one thing you remember, this is openly available, the voice is available, fingerprint is available, right. You have given some place in fingerprint, I have copied it and I have extracted the features and I have used. So, you can tell that my biometrics information has been stolen, or by some means I could get your biometric features and I have entered into your system, right. That is also possible. But at the same time, you keep in mind that we use biometric system to avoid the reputations. That means, what we are telling that the protocol that tells that you cannot deny that you have not done these things, that is possible through biometrics, right. That is our claim. But here at the same time, on the first part, what we are telling that no, sometimes it may so happen the genuine user may tell no, I have not done, somebody has stolen my voice, somebody has stolen my fingerprint, so I am not responsible for that, this may happen. So, these two contradicts each other, and as a result one solution could be like this, that okay, whatever action you do it, whatever image you give, I store it, keep it for future purpose, and if you disclaim or if you claim that no, it is not my, I have not given the data, then I can extract the image and I can prove that yes, it is you have given the data at this situation, right. But one issue is coming up, in that case that image becomes in public domain, right, because you are not the person who will be analyzing, it is another group who will be analyzing that yes, whether you have given the data at that time or so or not. So, image becomes in public domain, the privacy may be an issue here. It can lead to identity theft or the system compromise. Biometrics are not secret. So, the technology exists to get your photographs, whether you with your permission, without your permission, to get your fingerprint with your permission or without your permission, this technology exists, right. And once it is there, so you cannot claim that it is a secret, right. So, from the privacy point of view, you always tell that biometric data, I have to retain it, it is a secret, it should not be shareable and all those things. So, there is a contradiction between the two statements, right. So, one way one can think that the data whatever you are getting or biometric data, can I make it secret or revoked, right. So, this is also possible that you move the data in such a way that it becomes that encrypted, right. You cannot be, no one can get it back, right. Now, this is also possible. Now, let us understand, if it is the possible thing that once you give the data and it is revoked, it is encrypted by some means, and now that you have a compromised system and that is allowing the people. So, he will not be, you are thinking that he will not be able to do it. What you can do that you, if in case there is a problem, you just change your fingerprint data or your biometric data and again you start using. But here again the problem is that you cannot change it, because that compromised system also changes that environment. So, there will be a big problem for you. So, this is not a correct, so this is that implies the biometric systems, biometric data is secret itself is a contradictory statement. You cannot think that it is secret all the time, or you can manipulate through some encryption thing. Now, sometimes the biometric data we use for secondary purpose also. Suppose an individual has given the biometric data for multiple purposes. Now, if the organizations, the different organizations share that information, because I have given my fingerprint, why shall I give every time? I have given my fingerprint, face data and other data to different thing, and I want to use same data for multiple purposes. That means what? The organizations will be sharing that data. So, if it is there, then user can be tracked using by that, but at the same time, how can you tell that privacy is retained, right? And another aspect in the case of secondary users, that driving license is designed with the requirement to prove the identity, and driver's certification to a police officer, but it is used to prove the name and age also, right. So, this is also multiple use of your example of multiple use of same data. So, initially you have used it for what? For driving purposes, but it is being used for other purposes also. Okay. Now, let us think about, that there are a biometric system consists of several subsystems, agreed, and now each subsystem is connected with another subsystem. So, vulnerability can occur at any stage in the subsystem or in another, in the link or connection between the two, at that time also it may occur. For example, if you see this diagram, you come and you give your data, right, you present the data that I have come and present the data. So, what it means that I have come and you have to say, as you have given your data in the for other card, what you did, you have gone there, then you have given your high school certificate or address proof and so many things. So, you tell that yes, I want the Aadhaar card, I have this data, and they have also given the set of papers you have to bring. So, they check yes, you are eligible to provide your data, then you provide the data to sensor. Once the sensor gets the data, then you will be extracting the features, segment, first segment, then feature extractions, and then quality control. If quality fails, you have to do again. If it is a successful, now you will be generating the template, and once it is a first time template generated, so it will go to the enrollment place, that means the database, data storage, and if it is for verification, it will go for matching. So, it will match from this, it takes the two data, match, and then he takes whether it is verification or identification. Based on this, they will take the decision. Now, you observe that wherever I have written A, B, C, D, E, F, G, H, this all of them are the point of vulnerability, right. The vulnerability can occur, may occur here, and may occur here, template generation time, then data storage time, matching, and so on. So, you have to understand how it is happening. So, let us first think about identity claim. What is the vulnerability there? Identity claim is not a biometric system, that you have come with some papers and you want to prove that I have come and I want to. So, but this is also indirectly essential part of your biometric system development. Even though you have that paper is not useful, but it is essential. For example, here in the simple case that you have a season match is there, season ticket is there, and you are carrying every day you go to see the movie or to see the game. If you have the ticket, they will not ask, right. And again, if you, even though they write that it is not transferable, but if you give the season tickets to somebody else, he also will enter, because it does not mean anything, because he has paid money for so many tickets and he is sharing. It is not a big issue. Now, think about the highly secured documents case, the passport, right. You have passport, yes or no? Everybody has passport. Now, while filling, no, he does not have the passport. You do not require. You require. You have a passport. You do not have. You do not want. What for? So, you want to go abroad. No, there are several reasons why I need passport. You know, yes or no? Is it only for going abroad? For identification, what identification is there?
Some of the exam they ask only for passport or identity.
But what is identity? There is no identification marked here. Huh? They verify what? That somebody else has checked your candidature and I am honoring that candidature. Not beyond that, you cannot draw anything, right. So, same is the case here also. If you see that I want to make a passport, they tell you that you give your address verification thing. So, generally we give the address verification, maybe ration card, you have a ration card, no. Or if, see, remember one thing, ration card is the most important thing in life. If you do not have the ration card, you will not get the gas connection. Now, to get the gas connection, you need the ration card. So, tell me how to solve this problem, I do not know. So, you have to do some manipulation here and there to get one ration card first. Once you get the ration card, then you will get the gas connection. If you get the gas connection, then you get the address proof, because gas has been delivered to your house, right. Ration will not be delivered to your house, you have to go there to bring the ration. So, who is going where, nobody knows, but gas connection depends on, but to get the gas connection you need the ration card. So, you have gone to that, you have to fill the form where you have to show that address. So, generally people give the ration card address, and once you give the ration card address, who verifies the ration card? Nobody comes to verify. Generally, I have not seen that anybody comes and checks whether this address is correct or not. Based on that they give you. So, less secured system is giving you some authenticated things to get the higher secured things. That is the thing. To get the passport, you need the address, and that address is proof you are getting from the ration card, which is lower level secured environment. Am I right? So, this itself is this passport you are going to use for further processing, as you are telling. So, if it is based on the weak authentication system, then everything is gone. Now, the presentation is another one. Just you have come with the data, that whatever data, and you are presenting in front of the sensor yourself, and then you have to tell I want my authentication thing, or enroll, I want to enroll myself, right. So, this is an attack on the biometric sensor. This attack will introduce either the false biometric sample into the system, Such attacks are designed to either avoid detection. So, you will be giving this so that you will not be able to detect. So, false negative or masquerade as another, that is false positive. Now, that avoiding detection is much easier problem compared to the masquerading, because that in the case of avoiding detection, just say for in the case of fingerprint, I just cut my finger and I give this. So, you will not be able to, because I have come with my fingerprint, there is no ambiguity. I have come with my fingerprint, I have brought my materials, and now I want to give the data, whatever data I will give, my fingerprint is cut. So, features will be different, right, even though your sensor is good. But if I have to generate somebody else features on my fingerprint, that is a more difficult problem. The simple problem is that, okay, I want to avoid my detection, so I come with some cap, wrong fingerprint cap, I give the data, so wrong features will be extracted. It is very easy, but the other one is difficult. That no, I want to prove myself, I am not Falguni Gupta, I am Saiful Islam. Then his fingerprint I have to have, which is a difficult problem. So, presentation is one thing. So, the example is that you can, in the case of detection problem, avoid detection, you can put the makeup, right, you can put the moles here, you can put the beard, or you can put some fingerprint cap, or you can cut the fingerprint. These are all successful things. Now, if I know the algorithms in detail, how features are getting extracted, then this attack is much easy, right. So, suppose I want to make the full of my system, and I provide my iris data in the reverse order. The head is bottom and leg is up. In that case, my system will fail, because my iris algorithm works only for few degree rotation, right. So, these are the issues in front of your presentation. Now, sensors is also another place where the attack can be possible, right. So, one way could be that you put the poor quality device, right. So, quality is always giving you the wrong, poor quality, and you will become fed up, and you will know, I will not use your system. This is possible, right. But in the same time, so in that case, what happens that you can completely bypass the system. You can directly go to the operator that I am failing every time, so can you help me? So, he will use his own thinking, and the system will be broken, right. So, in some cases, that what happens that whatever data you give, he replaces his old whatever stored data is there, he transmits that one for feature extraction. So, I have given my image on the scanner, but scanner is not accepting, even though he is showing you that he has accepted your image, but he is transmitting not your image, somebody else's image, right. whatever he has in his cache, he is transmitting. So, that way also he can bypass the system, and so this is always under the control of attacker. So, the attacker decides that whose data has to be transmitted from the sensor. Now, sensor has transmitted the data. The data transmission means that image. Now, that at this image segment you have to get the ROI, that image segmentation you have to do. This point is also there is a vulnerability. Where is the vulnerability? Because system has to detect the ROI. So, there may be some case system is not able to detect the ROI. For example, I have used the surveillance camera to get your face photographs. You have given your face photograph, there is no problem. System has collected your face. Now, to get the to detect your face, I have used the 2 eye black part, that black portion of your eye or iris I have used to obtain your ROI. Now, suppose surveillance camera is at a such that your system is able to detect only one eye. Either one way that you have closed one eye, or system has collected the data such that another eye is not visible. Then the system will not be able to detect his ROI, right. Similarly, the case with the, suppose I use the core point in the fingerprint, there is a, you check there is a center point, that center point I use to detect my ROI, but it is not essential. He is looking up to whether there exists a center point or not in his finger, may not be there, but most of the people are having the center point. Center point is there where you will find that all curvatures beyond that is going up, there is one point, it is known as center point. Now, suppose there is a cut in the center point, right, area is very small. So, it is difficult, or it will be difficult for any system to obtain the ROI in that case, because this algorithm works based on the core point. Next one is feature extraction level. Is it vulnerable? Right? This module input is the ROI. Now, if it has passed through ROI, that means he has got some area of his fingerprint, and from there you have to extract of his biometrics data, and he has to extract some characteristics from there. So, it can be used for both the cases. One is that I want that imposter should be in, that means forgery is allowed, that I want that his case should be forged, or I want to see that he is not allowed to enter into the system. In both the cases, that means that a genuine user will be rejected and imposter will be accepted. Feature extraction level forgery or attack on this can work for both the cases. Now, but in order to do that, you have to know what feature extraction algorithm he has used, right. Otherwise, you cannot manipulate or you cannot attack. So, the knowledge of the feature extraction algorithm is very useful, right, in this case. So, that if you know that one, so you need to generate some special features. Say I have the fingerprint minutia points in that things, I need to reject his case. So, I have to introduce extra minutia points, right, and those minutia points should not be the minutia points whatever he is having, first one. Or second one is that no, I want to reduce some of his true minutia points, or I want to introduce some true minutia points, so that the candidate will be accepted even though he is an imposter, right. In that case, he has to know the algorithm, not only that, he has to know the person's minutia points, which has to be entered into the say forcibly. So, how to characterize the extraction feature extraction algorithms? So, as I told you that you have to understand the algorithm carefully. See, in the case of face, you can think that I am designing a feature extraction algorithm for face. Here you have to understand whether he is considering here into account or not. If he is considering in his ROI, here is into account, then it is a different problem. Then he has to think that how to get the features where your ROI contains here also. Or in the case of iris, you can think that whether eyelid or eyelash regions are thrown out or not. There is some algorithm where you will find that no, I have considered both eyelid and eyelash. Some cases what we have seen that I consider that eyelid and eyelash area, if exists, that exists in the upper part of the iris. So, I do not consider, I take only the bottom part. Some area we consider this eyelash or eyelid as an occluded area, I do not consider. So, there are different ways one can think. So, you have to understand all these cases to introduce new features in the system. Most of these biometric recognition algorithms are proprietary. So, even though you know this, but they are proprietary system, right. Nobody will tell you what algorithm has been used to develop the system, but that means it is proprietary. But unfortunately, all these feature extraction algorithms are based on from the algorithms available in the literature. So, you have to understand the literature algorithm available in the literatures, and you have to find out what algorithm he has used. Based on that, you have to act on it, right. So, this is the about your feature level attack. Quality control, as I told you that once you have extracted the features, you will be checking this quality and you will be telling that this quality is poor. If it is poor, then you will be throwing back telling that no, you have to provide your data again, right. So, this is one point where you can always reject a person or always accept a person. See, evaluation of the biometric sample quality is important to ensure the low biometrics error rate, and during enrollment you verify always, you have to verify because quality is poor, because I am always expecting that my data in the database must be very good. So, you will be verifying, and you remember one thing, that this is a factor where a quality you can always declare that it is poor. Even is a poor quality data, you will be telling no, it is good. If good quality data you are telling poor, then you are throwing him out from the enrollment. The person will be giving the data again, and every time you will be telling that no, it is not good, and exception handling may be coming in between, because he has not been able to provide his data, or it may so happen that you are falsely rejecting a person, right. If every time I am giving and your quality is poor, and ultimately the concerned operator will tell, okay, let us accept this data, and then system will throw him out. So, false rejection will be there. And if you make the poor quality is very good, what happens? That everybody's data will be accepted for the enrollment or for the verification or identifications, and you will find that false acceptance rate will be high, right. So, the quality, this is also one vulnerability, that quality control at that level it may occur. Now, once quality is passed, then you will be generating the template, and template is a feature vector. It is assumed to be unique, and if I can manage to get this template, if I can attack this template, everything is gone, right. So, it is a one way function, because inverse you cannot, we are assuming that you cannot do it, even though now work is going on, but inverse is difficult. So, if it is difficult, then you automatically you cannot regenerate the ROI, right, because it is not invertible, right. But what we observe that no, there is a possibility, or you cannot prove that it is impossible, it is not possible, there is a possibility to regenerate the, once I can regenerate my image or ROI, then I can do lot many things. You think about this way, that I know the given minutia points of a fingerprint, this is given or is known to you. If I manage to get ROI, then what happens? Once ROI is known, I can put ROI and get the fingerprint cap on rubber fingerprint cap, so that you can put it. Have you seen any episode in CID? Have you seen CID? No, that is a morning time for you. CID? Nobody has seen CID. Huh? No. All such type of thing you will find there. So, you know, what he has done in one episode, that from the template, he has obtained the image, ROI. And from ROI, he has gone to a person who develops the molded materials. So, he got the fingerprints cap, and he put the cap and he has done all the work. So, this is possible. But only thing is that you have to understand the amount of effort is required for that. So, that is important. The amount of effort I have to put, that much, my value must be much more than the whatever I am putting my effort, right. So, that is important thing. This is a big problem. This is we are fighting like anything, everybody is fighting. That nobody wants to get a system which has the monopoly business, right. Say for example, there is a vegetable supplier at your hostel. The same vendor comes. What will happen? After time t, he will start cheating you. So, you have a committee. You decide that I will not accept the data or vegetables from him only. I want to get from some other people also, right. And so that I am not dependent on him, so he cannot cheat me. Only issue is coming that everybody has certain steps of or methods to follow to produce the output. Now, the method you will be following for producing the output, given the input same from the same area, it should give the output properly. But if I take the input from some other place, it should also give me the output. That is the thing, which is may not be possible. For example, I have in my case that I have sensor, then I have ROI detection. Am I right? That I have to pre-process, extract, enhance the image. Then you have the feature extraction. Then you have the matching, and finally decision, matching and decision. This is the thing you have. Now, I have a sensor A and a person subject has come. On the same sensor he has given the data, he will be getting the 2 ROI and 2 features will be extracted, finally matching will be there, right. Now, I have, if I am dependent on him, then whatever lifelong I have to take his help, right, because without him I cannot survive. Say suppose I introduce the fingerprint biometrics in the bank and I decide that cross match is the supplier, then cross match I will be dependent on cross match company, otherwise I will tell my system will not run. So, the bank will tell nothing doing, it should be free to me, from whom I will decide, I will get the sensor, my system should work. Now, what happens that I can introduce that, okay, no, there are two systems A and B. Now, from A, I will be extracting the ROI, and from B also I will be extracting ROI. Then it is FE. Finally, whatever features are there, that should be matched and give the genuine output. If I use the two images obtained from one scanner, whatever output you are expecting, if I use the two sensors to get the image, I should get the similar matching score. But in reality, you will not. So, what happens that I have the two sensors, I have given one data here, same figure I have given here, but while I have used, now ROI is his ROI, and this ROI of extraction is from this algorithm, feature has been extracted using this algorithm, feature has been extracted using this algorithm. Now, these two features, even though you tell it is a say particular standard is there, then also there is something hidden. Somebody may be using 1 byte information, somebody is using 4 byte information, somebody may be that from the center onwards you are doing center, then nearest neighbor and so on, somebody may be from the top corner, all sorts of things is there. And matching algorithm, whose matching algorithm you will be using, whether his matching algorithm or this matching algorithm to take the decision, that is also will be coming in between. But whatever it may be, my matching score should be same or similar to the other one. So, the problem becomes here, I have two let us say 3 sensors. So, what government of India or any government expects that one image I will be extracting from there, another image I will be extracting from here, and I will be using suppose his ROI of A to extract the image, right. I have extracted the image or ROI from the ROI extraction algorithm of first one, then I must be able to use on this ROI feature extraction algorithm of B. So, features are extracted using the algorithm B, but I will be using the matching algorithm of C. If I do it and if I get the similar matching score, then I will be able to tell yes, all these 3 systems are interoperable. Okay? But this is not the case, because every vendor has certain hidden things and certain proprietary things which he does not want to share, because in the standard in ISO what we tell that you have to, your algorithm should be on minutia points, it should be on 500 DPI. I cannot tell everything that you have to do this, you have to follow this, then nobody will be able to do the business, because somebody has to prove that my algorithm is better than him, so he has to do some work. So, that is hidden, right. So, in some scanner image size is x comma y, the another image one is image size is not x comma y, it is x dash comma y dash. I am telling only 500 DPI or 500 PPI, 500 pixel per inch, but I cannot extract, I cannot tell what is the image coverage, that is not defined, right. So, I have somebody is having the size x comma y, somebody will have x dash comma y dash and so on. Now, once I use this ROI extraction algorithm, it may be dependent on the fee, because I have to make it monopoly, he wants to make it, everybody wants to make his business monopoly, but I am a businessman, I do not want others to enter into my area. So, what I will do? I will read my data based on this fixed x y. If it is a variable size, he is in problem. So, the system will not be able to detect properly R y. This is first type. Suppose there exists a system which reads the data of variable size. So, suppose the R y can read the data at variable size. Now, feature extraction will be coming. Now, the features he is extracting from the variable size may introduce too many false feature points, right, because the smaller size, suppose I have this one and another one image is very smaller size image, and this one he is habituated with the extract the feature on the smaller image. I have a larger area, then he has extracted, but he will get some false points here, right, because his data is original data is this one. Now, you have asked to obtain the features from this side. So, some false data will be coming, as a result false match will come. So, interoperability should be one where the sensor of different type, a feature extraction algorithm I must get from somebody. Somebody may develop the feature RY extraction algorithm, somebody should be able to design matching algorithm. I must get the similar results what I used to get from using only one sensor, but this is not possible. As a result, you will find that lot error rate is very high, right. So, as a result you will find that false rejection rate or false acceptance rate is very high. Now, the next one is that you have extracted the features at the enrollment stage, you have to store the data into the database. How to store the data, because this will be used for verification and identifications. Now, in the data storage also there are several ways you can think. One is that I can, while storing the data, I will not take much time, give me 4, 5, 6 minutes. The data storage type, what I can do, I can, what features you have extracted, I can add some additional information in that, add some additional feature points, right, or I can remove some, delete some of them. This is possible, right, very simple. I just while storing, I put some extra things or I remove some of them. This is one level. Or I put the template into another area for secondary use, and once I put that input in the secondary storage feature into secondary area, then you are gone, because your data can be taken by somebody else, or I can modify your identity. Even though you have given your data, I have extracted the feature, but while storing, I am not storing your features, I am storing my features, right. I have extracted, everything is extracted, but once I know that your ID is 35, and instead of storing your data, I will store my data. So, whenever you come to withdraw money, I will also give my fingerprint and I will withdraw my money, your money, not my money, right. That is possible. So, there are people, they think that okay, this template can be encrypted before storing, you just put encrypted, so that this is not possible. Now, this is what happens, that even though you store your data means feature points, but rule says that your information should be in public domain, your name, your date of birth, your fingerprint, all those things should be in the public. That is the government's rule. Otherwise, what is the guarantee that you have not stolen or you have not misused my data? And at the same time, I must know also that yes, you have put my data into the database, right? Because if I give my fingerprint, my name, I can generate, and suppose my left hand fingerprint, and I can match with his left hand by replaced by that. So, all those things. So, I must know that what are the features you have put into that, this should be available to the public. And once it is available, So, there is a chance of identity theft. So, in many cases attacks against template data transmission may be easier than template storage. So, generally we do not, one way is that instead of storing the modified template into the database, while you come, I know that he has come. So, I will put, suppose I know that he has come to withdraw money and he has given his fingerprint to withdraw his money. So, that while he has given the data, I will see that it has gone to somebody else, right. So, that is the template store. Instead of storing on touching the template storage, you work at the time of transmission. I think two more parameters, matching and decision. So, what biometric matcher does? Given the two templates, he matches and it tells that okay, this is the matching score. Now, attack can be done there itself, right. What is that attack there? I can see that even though the matching score is high, forcibly by introducing some method, I can make it low, right. So, that is possible, or what I can do, you have the, suppose I want to fuse the multiple biometrics data. So, you got a matching score here, you got matching score for this, and this matching score is also replaced by this one. That is also possible. So, you may get different type of things. Say I have one system B1, another system is B2, and you got a matching score M1, M2. So, if I fusion is just addition of two matching score, assuming that both of them are normalized similarity or dissimilarity things. So, I add it, I get one matching score. This is one way I get, but what I can do, I can attack by replacing this one by this number itself. Again, simple way, nothing, I have not done anything. This can be done very easily, and you will be able to reject or accept, or you can get very good matching score. The other one is the decision. So, even if you get the matching score, now you have to take the decision whether it is accepted or rejected, right. And if because it is the last component, after that a person will be allowed to enter or will be rejected, right. So, what do we do? I can stop you to enter by increasing the threshold value, simple, nothing else. So, I put in my database, if this ID is there, then their threshold value is very high in my system. So, if you come 35, I have given your, everything is through, at the time of matching score, you got the very high matching score, but I have put one condition that for 35 threshold value is this. So, you are out, right. Or I can do some manipulation, because operator is involved in between, right, operator will be coming. So, you will be coming, you will be giving the data and you want to get money, and operator will put some indication that yes, I do not want that his case should be considered. So, he put some key there, or which indicates that he wants the high threshold value for a similarity match, and you will be out. So, after time t, after several transactions, you will be told that no, you cannot get money. That is possible, right. Or you can always tell no, this is not giving me a good result, so I should reject this system. You get another system which is compromisable. You can compromise with that and you can get the better deal out of it. So, these are the different types of attacks possible on different modules and the interconnection between the two different steps.